Institute of Business and Computer Studies, Bhubaneswar, Odisha.
Good afternoon to all of you. Welcome to a new video from IBCS. In this video, we are going to discuss about the subject Database Management System. In all the previous classes, we have already discussed about the introduction to DBMS, the characteristics of DBMS, what are the differences between database system and file system, DBMS architecture, data models, instance and schema. Next, we have discussed about ER model. ER model is otherwise called as entity relationship model. We have discussed about different types of entities, how entities can be related to each other with the help of the relationship. We have also carried out few exercise from ER diagram. In this video, we are going to move on to the third unit, which is relational model. In the relational model, there are two topics that we are going to discuss. There is relational algebra that we are going to discuss in this video, and the other topic is normalization, which will be covered in the next video. So let us start with this video.
Today we are going to discuss about the third module, which is a relational model. All the related topics of this particular module. Let us take an example of a relation. A relation is generally a table in a database. In this relation, there are three attributes, which is account number, branch name, and balance. And there are different number of tuples. To be exactly, we have got 1, 2, 3, 4, 5, 6, 7. 7 tuples are there in this particular relation or table. Now we have to understand what is a relation instance. The current value is generally called as the relation instance of a relation specified by a table. So what can happen is this instance may change. So for example, today the first tuple that we see, Jones, and the customer street is Main and the customer city is Harrison. Tomorrow it may so happen that Jones may move from Harrison to some other place, so the customer city will change. As I discussed in the previous slide, here also in this particular relation there are three attributes, which is customer name, customer street, and customer city, and there are exactly four tuples. Generally the tuples are represented by rows and attributes are represented by columns. In a relation, the order of the tuples is not important. We can have the tuples in any order, which does not make any difference to the user or to the manager who wants to access the information. At the bottom of the slide, you can see the relation name, which is customer. So what will happen is, here there are three things that we have to know. The first thing is the name of the relation. Here it is customer. So every relation has got attribute and every relation has got tuples. Next we discuss about database. And database is generally a collection of multiple relations. So in one database we can have a number of relations which are related to each other. For example, in this slide, in this particular database, there are three relations. The first one is account, second one is depositor, and third one is customer. The account relation will have all the information about the accounts. The depositor relation will have the information about which customer owns which type of account, and the third, which is customer relation, will have the information about all the customer related to a bank. So now in this particular slide, you have to pause the video and answer three of my following questions. Question number 1, what is the name of the relation? Question number 2, how many attributes are there in this particular relation? And question number 3, how many tuples are present in this particular relationship? Pause the video for the next 10 seconds, write it down on a piece of paper, and then continue with the video. I hope all of you would have answered my questions correctly. So the answer is the name of the relation is customer. There are three attributes and the number of tuples are 12. Now let us start with relational algebra. Relational algebra is generally a set of operations which are carried out on a particular relation or more than one relation. So here in this video we are going to discuss about three basic operators. The first one is select operation, number two is project operation, and number three is union operation. Each of these operations are represented by a particular symbol. The first one, select, is represented by sigma. Number two, the project, is represented by pi, and the union is represented by u. As we go forward, we'll discuss each of these operations in detail, and then we'll try to carry out few of the examples for each of them. So the first one is the select operation. This select operation selects all the tuples that satisfies the given predicate from a given relation. The notation for select operation is given in the slide. So it is sigma, the subscript is p, and within bracket r, where sigma stands for the selection predicate, r stands for the relation, and p is the prepositional logic formula which may use the connectors like and, or, and not. These terms may use relational operators like equal to, not equal to, greater than equal to, less than equal to. Let us take an example and try to use the selection operation. So here in the slide, as you can see, we are trying to find out all the tuples from the relation book where the subject is equal to database. In the next slide, I will be showing you the relation book in which there are different attributes which the table will be used for this operation as well as all the other operations on this video. So this slide shows the relation book, and here we have got four attributes, which is book name, author, subject, and price in rupees. And here we have got five tuples for this particular relation. Now this slide is very important because this slide will be used in all the other exercise on this particular video. The next slide we will try to find out the solution for the question that we asked in the previous slide. So as you can see from the solution, the relation books, there are only two tuples that are selected from the books, because here in both the tuples the subject is database, and our expected output was we have to select all the tuples from the relation book which has the subject database. Here there are few questions that you can do for practice, and for this practice questions you can use the same relations book. So question number 1 is, write the relational algebra where the output is to select the tuples from the relation books where the subject is database and price is rupees 450. Question number 2, write the relational algebra where the output is to select the tuples from the relation books where the author is Kunz or the price is greater than rupees 500. Question number 3, write down the relational algebra to select the tuples from the relation books where the author is Smith and the book name is Essentials of Management. Pause the video here and try to work out the solution. The second operation is the project operation. In the project operation, it projects the columns that satisfy a given predicate. The notation is given by pi. In the subscript, we have A1, A2 up till AN, where A1, A2 up till AN are the columns or the attributes, and within bracket we have the R, which is the relation. Now duplicate rows are automatically eliminated as relation is a set. For example, let us try to find a query where we have to project the author and the subject from the relation book. We will be using the same relation books for this operation also. The answer to the query that was asked in the previous slide is shown in this particular slide, where we have successfully projected two columns or attribute. One is author, another is subject from the relation book. This is another practice question from the project operation. Here you have to write a relational algebra which projects the book name and the price from the relation book. Pause the video here for few seconds. Take a piece of paper and a pen and write down the solution and see whether you are able to write it correctly or not. The third and the last operation is the union operation. It performs binary union between two given relation as defined as follows. So the notation is R union S, where R and S are either database relations or relation result set. For the union operation to be valid, the following condition must hold. The first one, both the relation R and S must have the same number of attributes. The attribute domain must be compatible with each other. So let us take an example and see how union operation works. So let us say we want to project the author from the relation book union. We want to project the author from the relation article. We must keep in mind that both the relation books and articles must have the same number of attributes and all the domain has to be compatible with each other. So the expected output of this query is just the list of authors from both books and articles. The books relation is already discussed previously in the previous slides. In the next slide, what I'll do is I'll give you the articles relation. So this is the articles relation. Now here, instead of the book name, we have the article name, we have the author, and the subject and prices are absolutely the same. So that is why I tell you, though articles and books look different, but they are the same because both of them has the same number of attributes. So this is the answer to the query that we have asked based on the union operation. So here what has happened is we have listed out the name of all the authors who belong to the relation book as well as who belong to the relation article. Only one person is more in article, which is Malhotra, but rest of the author are absolutely the same. I hope all of you have enjoyed the video and thanks for watching the video.